Test statistic is actually, you only use SPSS because they didn't give us the thing. They didn't give us a link for that one. And so we have to figure it out by hand. Like by calculating.
Oh.
Right?
For number 3.
Uh-huh. And so I think that one is the X bar minus the mu over n root standard deviation, I think. I don't remember actually.
So is that solving for t? Is that what it is?
Yeah, t is test.
So yeah, the x bar minus mu over the standard deviation over the square root of n.
Yeah.
But do they want us to solve it for the 2? Yeah, so the before and after. So instead of doing that, it's the t equals d bar minus 0 over the standard deviation over.
Is it d bar?
Mm-hmm.
Oh, okay.
Because you're computing the before x and the after x.
So it's 2.2 minus.
So. Minus 0.
And then it's over 9 divided by root 3.3.
So I got 0.444.
Yeah, that's what I got, and that's what I got the first time too, but it said it was wrong.
Well, hold on one second. So the square root of 9 is the sample size? I got 2.
Yeah, wait, how did you do it? You did 2.2 divided by parentheses 9 divided by square root of 3.3?
No, you got to do it 2.2 minus 1.
Oh, minus 1, not minus 0?
Wait, why is it minus 1?
0. It's minus 0. Here, this is how I did it on 9. Let me flip my... Oops. Spin that. Okay, so this is how it looks, how I did my... Oh my gosh, my glare is ridiculous. So this is how I did it. The 12, you have to do the top one in parentheses. Did you do the top one in parentheses?
Wait, what's those bottom numbers you have? Is that what? Oh, so you have square root of 9?
Yeah, because that's the n.
Oh, because I did 9 divided by square.
This is the formula.
Oh, okay. So 9 is n. Okay, so I flipped 3.3.
Oh, that's what I did too.
Oh.
I actually didn't know that was the equation. I thought it was the other way around.
It's the, like, there's just 2 different ones for when you're doing, like, a paired test.
Oh, okay.
So 2. Oh, yeah, because the square root of 9 is 3, and then 3.3 divided by 3 is, right.
Let me try to grab my...
Cool. So then I think you use the applet for the next one. And then you just put 2.
Okay.
Oh, I don't even have the applet open.
Okay, so you got 2 in there for our area or for a z-score?
I think you put it in for your z-score because the area is a probability. That's what that kind of scares me to say that, but
the probability of obtaining a test statistic is greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
Yeah, and so your p-value is what you find up there.
Oh, okay.
Right? Little sketch, yeah. But I think...
so it's the whole area within the 0.9545?
Wait, what?
What? I'm so confused. What are we... What? I don't even remember using the applet for this lesson. All right, the probability...
I think that's what you do.
This probably.
I don't know. I honestly don't know. So let's try it that way.
Wait, so Luke, what did you think it was?
No, I was just so we put in the z-score to the
Uh-huh.
applet, and I just shaded the middle area, which was the 0.9545. And I was just curious if that was the number.
I think that would be. Let me read the question again. The probability of obtaining a test statistic greater. Okay. Use the probability to determine the p-value of Jordan's hypothesis test. Yeah. I think that makes sense to me.
Wouldn't it just be the two tails, or would it be the whole middle? I don't know.
I think it'd be the whole middle.
Okay, so the point.
Reject.
So 955.
So 0.955.
Yeah.
And which equation are we using now to find the p-value?
I think that gives you the p-value.
Well, so that's just the p-value then.
I think
The
so.
p-value is the probability.
Yeah.
Okay. So then why is it giving that number the 0.0403?
Because that's the probability of it being above what he has.
Okay.
So maybe it's just 1 minus that.
Yeah, that's what I was just thinking. I was like, is it just 1 minus that?
Well, I guess
Yeah.
I guess that someone can try that and then another person can try the other.
Yeah, I can try the other. I'll try the 0.955.
Okay.
I'll try the 1 minus
0.959 960.
It's almost the same. Like
Yeah.
it's so I'll do the 0.60.
Okay. Sounds great. Okay. And then question, I don't know if you guys want to do it.
5? Oh yeah, so we
Yeah.
already pulled that up, right?
Yeah.
Yeah. So I got for question 5, the test statistic is 0.407.
Let me run mine real quick.
Okay.
I got it too.
Perfect. And then for 6, I got the p-value as 0.689.
Yep, mine too, 0.689.
Yep.
And then, so question 7, what is the correct decision based on this evidence? And so since the p-value is greater, then it would be fail to reject.
Yeesh.
Okay.
Suppose your alternative hypothesis is instead greater than 0. What is the correct decision based on this evidence?
Well, it's not that we have sufficient evidence that the mean is equal to 0.
It would still be the same.
It's not sufficient evidence?
It would still be insufficient evidence, not sufficient.
Okay, so it'd be
because the p-value wouldn't change. So it would be the p-value, we have insufficient evidence that the mean is different or equal to 0, or what was the...
So it would be we have insufficient evidence that the mean of the differences is equal to 0?
It's greater than 0.
Greater than 0? Okay.
Yeah.
Okay.
So the second one, we're deciding on number 2?
Yeah.
Okay.
And then question 9. Do you guys have that pulled up?
Let's see. Isn't that 1, 2, 3, 5. Okay, yeah.
Okay. So
Which is
n
greater.
is greater.
Okay.
Yes.
And the p-value is 0.001.
Yeah, that's what I got too.
Mhm.
And so that lets us reject the null hypothesis.
She's on like a video thing.
Okay, and so that will decrease.
So that means we would reject the null.
Mm-hmm.
Based on your response to the previous question, what conclusion do you make? That we have sufficient evidence that there is a mean difference between the two groups.
Yeah,
I
that's
think
what
I forgot to
supposed
put. I think that's a typo there, but
to.
it's supposed to be groups, right? Not
Right, yeah. Okay.
15.
So wouldn't this one be the middle one? The alternative hypothesis is usually that mu is greater than 0, or maybe it's not enough evidence. Oh, there's another one.
Wait, what? I'm confused.
We have seen the p-value depends on the alternative hypothesis. In general, which hypothesis would be the smallest p-value?
Wouldn't it be the top one? No. No.
Oh. So the larger the mu you
You think it's larger than mu?
have, no, I'm just trying to
Okay,
remember.
as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
I really think that there's not enough information because it does depend on the problem, because the lower two will give the smaller p-values just because we have to divide them in half.
Right.
But neither of them will make it smaller than the other, because for both of them you have to divide them.
Right.
So wouldn't it be just the not enough information one?
Sounds great to me.
Or
Which one, Alexa, do you think it's not?
I would say that it's not, that it's less than 0.
So not number 2.
Yeah, not the second one.
Yeah.
So that does make sense to me.
yeah, because like it doesn't, like,
Yeah.
because there's no other step between the two. So
Okay.
okay.
What is the point estimate for the 95% confidence interval? I don't really understand how you get the 95%, the point estimate, I mean.
Isn't that just the like standard number?
So it's 0? That's what I thought too.
No, it's not. Point estimate. The point
Isn't it
estimate.
1.96?
Why would it be that?
Because that's like
Yeah.
the that's like the standard
the
number
Z
that we
star.
have.
Yeah, it's the Z star is
Yeah,
the
the
point
Z star.
estimate, and that's 1.96.
It's one of those things.
Because it's from like that table that they give you as like the confidence intervals, how like
Okay.
the
Oh,
90%
right. That's right.
is 1.645 or whatever.
Okay, so it's 1.96. And then the margin of error. So for the margin of error, this kind of always confused me. Do you just subtract like the upper and the lower to find out the difference between them?
Yeah, so so you have like your mean, and then you just take your margin of error, subtract it from the mean, and then add it to the mean.
So I think the upper, it says it's 18.6065, and the lower, it says it's 5.3025. This is going to sound really dumb, but do you just subtract the 5 minus the 0 since it's the lower? Or is it just the 5.3?
Oh, are you talking about finding
that. I think it's that actually. So I think that the lower bound is 5.303.
Yeah. And then to find the mean, just kidding, 5.303. And then to find the margin of error, what we can do is we can add the 5.303 plus 18.607, we get that 23.91 divided by 2, that's our mean, is 11.955, and we do 18.607 minus that number, and that'll give us the margin of error is 6.652.
Is that how you find it?
That's how I find it.
Okay.
So does that make sense though? So I'm taking the
Yeah.
lower bound and the upper bound, adding them together,
Adding them divided by 2. Yeah, that makes sense.
gives me my mean, and then I just take that mean and subtract it from the upper bound.
Okay, cool.
Hey, sorry, my phone died.
Oh, where do we lose you?
Oh,
I
yeah.
don't look at this
17.
video thing when I do it, so.
Yeah, no, I have everything pulled up on here.
I was on 17.
17.
Yeah.
Okay, so we found that 17 is 6.652.
Hopefully.
Yeah. And then 18 is 5.303. And then 19 is 18.607.
Wait, say 18 again. Sorry, I got confused.
5.303.
Okay.
Okay, I'm gonna submit it.
Okay, sounds good.
I'm going to submit too because we have the 2 different answers for the one.
I just wait for a second.
Yeah, just hold up just for a second.
Okay.
Okay, I'm stopping.